last week we talked about how do we find the basic derivative of a function. So for this week, we will go into a more advanced method of finding the derivative. Okay, let me go over the first one. The first one is the product rule. The product rule is going to be useful when you want to find the derivative of the product of some two terms. So when you have two terms being multiplied, like f and g here, the derivative of that is going to be the derivative of the first function times the second function plus the first function times the derivative of the second function. So it's almost as if you still have the product, but the f and the g they take turn being the derivative, and you add the two terms together. So in Thai, people would say it's a na dip lang dip na, something like that. But so let me take the derivative of this guy. So I'm gonna just use the formula here. So it's the derivative of the first term. The derivative of the first term, that's gonna be 4x cubed minus 7. So you should be familiar with the basic rule already. Times the second term as is 5 minus x squared. So that's my second term stay the same plus the first term stay the same. So that's going to be x to the fourth minus 7x times the derivative of the second term. Derivative of the second term, that's going to be negative 1 minus 2x. So, and as always, you don't have to simplify. In this case, I'm just going to leave the answer as is. It's too much work to multiply this guy out and add it up. So that's the product rule. The quotient rule is similar to product rule, but instead we have the quotient of f over g. The derivative of f over g is going to look almost like the product rule, but it's going to be the derivative of the numerator times the denominator minus, notice that the sign is minus here, minus the numerator times the derivative of the denominator over the denominator square. So if I were to use this formula, I have here a quotient of two functions. So the derivative of this function, I can just go ahead and use the formula. That's going to be the derivative of the numerator. So that's going to be 2x minus 1 times the denominator, which is x, minus just the numerator, which is x squared minus x plus 8. Minus x plus 8 times the derivative of the denominator, which is going to be just 1. The whole thing over the denominator square, which is just x squared. So this is the result of the quotient rule. Now, there is also another way to actually find the derivative of this guy. You can actually simplify this guy and find the derivative as well. I can actually rewrite my function as x squared over x minus x over x plus 8 over x, which is going to be x minus 1 plus 8 times x to the minus 1. So the derivative of this guy is going to be 1 minus 0 plus 8 negative 1 times x to the negative 2. So this is also a correct answer. So that means sometimes there's actually more than one way to find the derivative of a function. If you simplify these two things, you'll see that they are actually the same function. So, well, again, so sometimes you can find more than one way to find the derivative of a function, but usually they will yield out the same answer. And you can do whatever method as long as it's correct. It's good. And also these formula are not going to be given on the exam. So you can see in the old test. So I will not give any of the formula that you see in this table and any of the formula that you see in this table. Let me do 2 more examples here. 2 over 5x. There's also more than one way to find the derivative of this one. Let me actually use the quotient rule first. So the derivative of f is going to be the derivative of the top, which is going to be derivative of 2 by itself is going to be 0, times the bottom, which is 5x, minus the numerator, which is 2, times the derivative of the denominator, which is 5. The whole thing over 5x squared. And that would just be my answer. So that's the derivative of this guy using the quotient rule. And like I just said, there's usually more than one way to find the derivative of a function. You can also rewrite this guy. You can see, wait a minute.
Doesn't have to be 5x.
Oh yeah, I mean, thank you. So that should have been, let me see, girl. Well, thank you. So that the square should have been outside the parentheses. So that should have been 5x squared. Thank you. However, some of you might look at this function and see, wait a minute, this thing, 2 over 5x, it's actually just 2/5 of 1 over x, or it's actually just 2/5 of x inverse. So the derivative of this guy is going to be just 2/5 times -1 times x to the -2. So once again, this is a correct answer, and if you look carefully, the 5 will cancel out, and this 2 is going to end up being the same thing. So once again, there's more than one way to find the derivative of a function, and they both give the same answer. Let me now try the last one. I have once again a product of 2 terms. So to find the derivative of this one, it seems I'm gonna have to use the product rule. So the product rule, it's gonna be, let's see, the derivative of the first term, the derivative of cosine is gonna be minus sine of x times the second term, which is x squared plus 4x to the 8 plus the first term, which is cosine of x, times the derivative of the second term. However, your second term, if you actually look carefully, your second term, this is x squared plus 4x to the 8. To find the derivative of this guy, you actually are going to have to use the chain rule to find the derivative of this one. So if I use the chain rule, the derivative of that is going to be 8 times x squared plus 4x to the 7. But because I'm using chain rule here, I'm going to have to multiply this guy with the derivative of the inside function, which is going to be 2x plus 4. So that's the derivative of this guy.